So this question is going to Javier, and Javier had asked a question about how it is that we can select the right trig substitution when we don't have like kind of one of our more standardized trig forms. So like the question here looks something like this, and it's the integral from the square root of 4x squared minus 25 over x cubed dx. And he wanted to know, well, how do I know what to substitute? And which is a great question. So the first thing I want to notice is that I've got my form is of the form, right? I've got my variable minus a constant, okay? I've got a variable minus a constant. And so when I see something like that, or variable squared really, minus a constant, I'm thinking to myself, right? And that's what's under the square root. I'm thinking to myself, well, you know what? I really want secant squared theta minus 1, right? Because that's going to be the trig substitution that I want to end up with. Then I'm going to change that into tangent squared, okay? And then, you know, I can, and then I'll change it into tangent squared, and then I can reduce, and I can do some other work, other algebraic work, in order to turn this into something that I can then integrate. So what I'm going to do here is I want to get this 25 into a 1, okay? And so how I'm going to do that is I'm going to factor out 25. So that's going to then give me the integral times the square root of, and this is going to be 25 times 4 over 25 x squared minus 1 over x cubed. And so I want to turn this into a 1, and you'll notice that that's then going to kind of start to look like exactly what I'm going to need for that secant squared theta minus 1. Then I'm going to factor out, or I'm going to simplify out the 25. So this is going to be 5 times the square root of 4/25 x squared minus 1 over x cubed. Okay? And we're going to find that integral. These are all dx. Okay? And now what I want to do is I want to say, okay, well, if I've got that, now I just need to actually turn this into secant squared theta. So I'm going to say secant squared theta, right, equals 4/25 x squared. So it's going to be 4/25 x squared. And that way, when I substitute in 4/25 x squared, I get secant squared theta minus 1. Now, what we don't want to forget is that we're going to also need a d theta. Okay, and we need to know what x is. So I'm going to now solve for x. So what I'll do first is I'm going to multiply by 25 over 4. And so that gives me 25 over 4 secant squared theta equals x squared. And then I'm square rooting, and just assuming that it's the positive. So I'm going to then get that 5 over 2 secant theta is equal to x. And that's what x is going to be. Okay? So now I've got to actually take the derivative of both sides in order to get dx. Alright, let's just go through this, make sure that this is really clear, and then we'll go on to dx. So what I did was I said, okay, I'm going to take 4/25 x squared, and I'm going to set it equal to, in this case, the secant squared, because I want to make a direct substitution there between those two. Then I'm going to go and solve for x just using some algebra. Right, so multiply by the reciprocal, okay, and then take the square root, and I get x equals 5/2 secant theta. So now dx is then going to equal to the derivative of 5/2 secant theta. So this is going to be 5/2 secant theta, tan theta. And now I have d theta. And now I have everything that I need in order to substitute to actually go out and solve this integral. So I'm going to plug that back in now. I've now got the integral. I've got 5 times the square root 4 over 25x squared. This term right here is secant squared theta. So this now is secant squared theta minus 1 over, and then x is 5/2 secant theta tan theta, or excuse me, x is 5/2 secant theta. So this is going to be 5/2 secant theta cubed, and then times, and this will be 5/2 secant theta tan theta, d theta. Okay? Now this is then going to equal, well, we'll take, I'm going to do some work with my fractions here, just as a side note, so I can get this all very clear. I've got 5, okay, times 5 over 2, because there's the 5 over 2, divided by, and this will be 5 over 2 cubed. Okay, so now one of the 5 over 2's gets canceled, so I have 5 over 2 squared. Okay, and by the way, that's the 5 over 2 cubed. I have 5 over 2 squared, and this is then going to equal, well, I will take the reciprocal of that. It's going to be 5 times 2 over 5 squared. This 5 will cancel. One of these 5s is going to cancel. Okay, so we're going to end up with just a 5 squared. Or, excuse me, just 5. So let me do this fully. 2/5, right, squared. Right, we're just going to bring it up to the top and take the reciprocal. And so I end up with 2 squared over 5, which equals 4 over 5. Right, that's handy to know. And so now I have the integral, okay, or I have the integral of 4/5, and this will be then the square root of secant squared theta minus 1 divided by secant cubed theta times secant theta tan theta d theta. And so I'll pull the 4/5 out. I got 4/5 times the integral. Secant squared theta minus 1 is now tangent squared theta. So this is going to be the square root of tangent squared theta, which is exactly where we wanted to be. Times secant theta tan theta divided by secant cubed theta d theta. And now this equals 4/5 times the integral of, and tan squared theta in square root is tan theta. So we're going to get tan squared theta. And then we're going to factor out one of those secant thetas. So this is over secant squared theta. Okay. And this then d theta. Okay. Now what I want to do is I want to simplify this. So I'm going to get 4/5, okay, times the integral. Tan squared theta is going to be sine squared theta over cosine squared theta divided by, and secant theta is going to be 1 over cosine squared theta d theta. So this is now going to equal 4/5 times the integral, okay, of sine squared theta over cosine squared theta times cosine squared theta over 1 d theta. Because we're dividing, we've got to multiply by the reciprocal of that. So those cosine squared thetas go away, and this ends up equaling 4/5 times the integral of sine squared theta d theta. Now I've got to go solve sine squared theta d theta. So I get 4/5, okay, and we're going to take the integral, and I'm going to make a trig substitution of 1/2 minus 1/2 cosine, in this case 2 theta, d theta, and that is then going to be 4/5 times 1/2 theta minus, and then this is going to be 1/2 times 1/2, and this will be sine 2 theta plus some c, although we'll get to the c at the end. So this then ends up equaling, or plus c, that's fine. This ends up equaling 1/2 theta minus 1/4 sine, or excuse me, not 1/4, but 1/4 times 4/5, so that's 1/5. So this is 4/10 theta, excuse me, because it's 4/5 times 1/2. 4/10 theta minus 1/5 sine 2 theta plus, we got some kind of c. We'll get there. Like I said, we'll get to c in a minute. This 4/10, let's just actually change that to 2/5. So 2/5 theta minus 1/5 sine 2 theta. Okay? Now, here's the deal. Okay? The problem that we have now with this particular one, kind of interesting actually, is that if you remember, x is 5/2 secant theta. And so we don't have a secant inverse, and two, we don't want to write things in terms of secant inverse anyways. We don't want to write like theta equals secant inverse of 2/5 x. That just doesn't work. What we're going to want to do here is we're going to want to set up a triangle, like we're going to set up a right triangle, and then inside of that right triangle, we're actually going to use that in order to find values for, like in this case, what sine 2 theta is. But because it's a sine 2 theta, and we want to change theta into x, we will need to change sine 2 theta into some terms of x. Okay, into terms of x. So I'm going to rewrite sine 2 theta, okay, equals sine equals 2 sine theta cosine theta. So now the solution to my integral ends up being 2/5 theta minus 1/5 sine 2 theta plus, or excuse me, 1/5 times 2 sine theta cosine theta. Okay? Plus c, and that's the value for my integral. And so now I have, again, I'm going to have x is equal to 5/2 secant theta. Right? Let's just go check, make sure that that's in fact what we had. 5/2 secant theta. So now what I'm going to do is I'm going to rewrite this as secant theta equals 2/5 x, or 2x over 5. And secant theta is equal to the hypotenuse over the adjacent, right? It's the flipped of the cosine. So it's hypotenuse over the adjacent. So consequently, we'll let 2x be the hypotenuse, and the adjacent is going to end up being 5. And because we're going to need sine, we're also going to need the opposite side. So here's theta, right? We want sine, and so sine is going to end up being the square root of 2x squared minus 5 squared. And if you've noticed as you've been working, you're going to notice that that's actually going to be 4x squared minus 25, which was the original value that we had in there. Okay? So, sine of theta is going to equal the square root of 4x squared minus 25. Cosine of theta is then going to equal 4x squared over minus 25 over 2x, excuse me. And then cosine of theta is going to end up equaling 5 over 2x. And then we need to figure out what theta is. Right? We can't, there's no such thing as secant squared inverse. It doesn't really make any sense. But one of the things that we could use is we could just utilize either the sine or the cosine. Either one. So theta is then going to equal, we'll make it cosine inverse of 5 over 2x. You could also use a tan inverse, I suppose, too. So now I'll plug that back into my equation. So my answer now is going to be 2/5 cosine inverse 5 over 2x minus 2/5 times the square root of 4x squared minus 25 over 2x times 5 over 2x. Then we'll cancel our 5s, cancel one of our 2's. And so this ends up equaling 2/5 cosine inverse of 5 over 2x minus, both of our 2's, the square root of 4x squared minus 25 over 2x. And there you go. So this actually was this one showed a lot of really interesting stuff that you could put in here. Let's kind of go through and discuss some of the interesting qualities or characteristics. One had to do with Javier's question about, well, what happens if we don't have, I've got 4x squared minus 25. Neither one of them is 1, right, in front of the coefficient. What do I do? Well, in that case, what you're going to do is you're going to factor out the value for, you're going to factor out that 25, the value for what we might call b, okay, and make that a 25 in this case. And then what that'll give you is it'll give you the original coefficient in front of the x squared divided by what you just factored out. Squared minus 1. Or whether it's plus 1, whatever it is. Your whole goal is to try to get it looking like one of these Pythagorean identities. Okay, like secant squared theta minus 1. So now I'm going to go in here and I'm going to set this value right here. I'm going to set 4 over 25x squared equal to whatever I want to substitute. Okay, so I'll make a straight substitution at that point in time, but then also I'm going to have to go in and solve for x. And I'm going to have to solve for x because I'm going to need to find dx as well. Okay, so we're going to have to do the solving for x so I can find dx. Once I do that, then it's just a matter of plugging things in and starting to work on, simplifying my problem, right? And sometimes that could be very involving, like this one is. So we went in, we plugged it in, we made the substitution, secant squared theta minus 1 for tan squared theta, right? We made even more substitutions, more simplifications, until finally we ended up with something that we could integrate, and we in fact did integrate it, right? So this form right here, this 2/5 theta minus 1/5 sine 2 theta plus c, that's all good, okay? So now, though, what we want to remember is that our original function was not in terms of theta. We're going to have to actually make a substitution. And that's where this one actually gets kind of cool, because if you have a sine 2 theta inside of your function, you're going to need to change that into 2 sine theta cosine theta, right? So that the variables match, right? The arguments match. The theta and the theta are the same. And we used another trig substitution for that too. And once we did that, we could rewrite our integral again, the value for our integral, or solution to the integral, with just single thetas. Finally, we want to go in, we want to construct a right triangle, okay, utilizing our original substitution. X equals 5/2 secant theta, okay, and the fact that secant theta in this case is hypotenuse over adjacent. So even more trig here, okay, and then from there, you're going to figure out what sine theta is so you can substitute, figure out what cosine theta is so you can substitute, and then in this case we needed a theta, so we used our value for cosine theta to find the value for theta, and we substituted all those in, okay, and that ended up giving us our solution after some simplification. Okay, so a lot going on in this one. It's actually kind of a tough one. But hopefully that first part helps you out, Javier, and for the rest of this might help out some other people too.